Today's webinar on all things Oracle database encryption. My name is Phil Ryman. I'm the Director of Business Development and Integrity, and I'll be the moderator for this e-learning session. The speaker today is Steve Coast. Steve is the Chief Technology Officer and the founder of Integrity Corporation. He's been working with Oracle products since 1994, and for the past 14 years, Steve has focused on the security and auditing aspects of the Oracle Business Suite and Oracle databases, and has written and presented on these topics at various national and regional conferences, including OAUG, IOUG, and the Regional Collaborative Conference, which, by the way, we will be attending again this year. I'll now turn it over to Steve.
Thanks so much, Phil. Today we're going to explore all the different encryption options within the Oracle database. And these encryption options include what most everyone is probably familiar with is generally TDE, which is the disk encryption. But we'll also talk about things like the network encryption, trying to encrypt data that's in use. So we'll start off with a brief overview of database encryption. Then we'll talk about data at rest encryption, then data in use encryption, and then finally data in motion. And then at the end, we'll open up some questions and answer. So before we get started, a quick overview of Integrity. Integrity was founded in 2001, and we specialize in Oracle Database and Oracle E-Business Suite security. And there's two parts of our business. One was we do have some products, one being App Sentry, which is a database security auditing tool. So it'll actually check and verify that you've set up encryption correctly. And then we also have another product called App Defend, and App Defend is an application firewall for the Oracle E-Business Suite. Our second side of our business is our services. So we do a lot of on-site security assessments, on-site security design work. So a lot of this presentation is based off of what we've done for clients in the past. So we'll actually work with clients and how to design and implement their database encryption solution throughout their enterprise. Another part of our business is also doing security research. So as part of the critical patch update that just got released this quarter, Integrity is actually credited for finding 40 of the security vulnerabilities. This quarter was especially significant for the Oracle E-Business Suite. So if you're running Oracle E-Business Suite, there were 78 security fixes, and it's a very high-risk CPU. So we recommend everyone start looking at the January 2016 CPU, especially if you're running Oracle E-Business Suite. So enough about Integrity, let's start talking about database encryption. So overview, why are you going to use encryption? It's primarily to encrypt sensitive data. So if you're processing credit cards in the database, you're storing them, then you need to adhere to PCI, data security standard. So all credit card numbers need to be encrypted. You may have some state privacy regulations. You may have to be encrypting information that's employee information, customer information, social security numbers, bank account numbers, things like that. If you deal with healthcare information, you have to apply to the HIPAA regulations that require you to encrypt certain protected health information. So the key is encryption is meant to really protect sensitive data, and that's what we'll focus in on in this presentation. So the first thing you always need to look at is, okay, what am I going to encrypt? Where is that data? And really the one most people focus in on is the application table. So I've got an application, it's storing some sort of sensitive data, be it credit card numbers, social security numbers, etc. And I need to protect that information. I may be protecting it from hackers, I may be protecting it from insiders. One area that a lot of people don't look at very closely is where else might that sensitive data be stored. If you're running a package application, you may know exactly where in the package application sensitive data is stored. So if you're running, let's say, Oracle E-Business Suite, Human Resources, you know in Human Resources the social security numbers are stored in the HR All People F table. Well, you may also have custom tables out there, so you may be not looking in all the locations. So when you're thinking about encryption and trying to protect all the sensitive data, make sure you're looking beyond the application. You're looking at the custom tables. Another key area that we find quite often is maintenance tables. So you may be doing backup copies. So any competent DBA, before they make a direct SQL update to a table, will always make a backup copy. So they'll just do a create table as select, and it's very easy to create those tables. However, now if you're thinking about and you're somehow doing encryption, you may be doing it at a tablespace level, you may be doing just a column level. How that is done and where that table is may not be encrypted anymore. So if you are running Oracle E-Business Suite and you actually do a backup of the PR All People F table, a lot of times they'll have a name with like a date on the end. So you need to be very cognizant of that, aware of where those tables are. Another key place is like interface tables. Often applications process and stage data temporarily. So if you have an interface coming in, it may drop off data into a staging table. That staging table is processed and then moved into regular tables. Well, that might be Social Security numbers. So if you have an interface to, let's say, Blue Cross Blue Shield, you may be bringing in data into an interface table. It may be stored there temporarily, but it may be stored there for hours, days. What happens when there's errors with some of the records? We often find these interface tables have significant amounts of data that's kind of stuck, locked. For some reason, the process doesn't delete it or something like that. So when you're trying to look at encrypting data within the database, be sure you're looking at just beyond where you know. Start doing some scans, looking at other pieces of the information. An area we won't cover in today's presentation is also at the file system level. So you may have to encrypt data there. So if you do have like an interface from Blue Cross Blue Shield dropping off a file that has Social Security numbers in it, you may have to be encrypting that data at the disk level. So we won't cover that. We'll talk more about just the native database encryption solutions, but you always have to be thinking about where is my data, what am I doing? And also have a full process. Our presentation today is really looking at just the encryption solutions, but encryption is only one part of the sensitive data puzzle. So when you're trying to protect data, first you need to look where it is. What am I trying to protect? What is the organization's privacy policy? Which tables are those elements in? So I need to get down to very quickly an element level. So is it Social Security numbers, credit card numbers? Is it date of birth? Is it other piece of information? When I talk about Social Security numbers, am I looking at not only employee Social Security numbers, but how about my 1099 vendors who use their Social Security number as a tax ID? So I might have some tables in my accounts receivable system that needs to be protected. What happens when I'm cloning these databases down to test and development? So you all have to be thinking about quite a few different areas when we're talking about data protection. Encryption is one part of the solution. It's a very important part of the solution, but you need to be thinking about some other areas. So that's kind of a high level of talking about sensitive data, but now we're going to delve deeply into the encryption piece of it. When we're talking about database and encryption, there's really three types of encryption that are important here. The first is storage encryption. So when data is at rest, so when it's sitting on the disk in the storage, and also might be removable media, is that data encrypted? If someone steals that disk, steals those database files, is that data encrypted? A second area that doesn't get as much attention at the database level, especially at Oracle databases, is data in use or access encryption. Am I able to use my encryption solution as also an access method? So am I blocking people access to the data because it's encrypted? And then finally, network encryption or data in motion. So when I'm moving data between two systems, is that data encrypted? And primarily with the Oracle database, this would be then SQL Net Encryption. And we'll talk about each of these in detail as we go forward. So when we start talking about some of the storage access encryption solutions, think of it as a couple different areas. There's application level encryption. And this would be, the application is actually written to encrypt the data. And this is very specific to applications. Some applications do this well. Custom applications may do this. Other applications don't do this very well. So again, with application level encryption, the application, every single time it's reading and writing the data, is encrypting it. It may be using native database encryption APIs to do that. Another area is database level encryption using views and triggers. You don't see this very often, but it can be a very effective solution, especially for custom applications. So what I do is I create views and triggers, and so every time I read and write the data, those views and triggers are basically providing me an interface to the data, to the underlying table. And so instead of querying the underlying table, I'd always query a view, and every time I write to that table, I actually call a trigger that would then encrypt the data before it's stored. That can be a very effective solution for a custom application, and that's often overlooked. Finally, what probably most people are familiar with is the disk and storage level encryption. That'd be transparent data encryption, or Oracle TDE. This is basically every time I read and write from the disk, I'm actually encrypting the data. We'll talk about in depth here what TDE does well, what doesn't TDE do well. So this is a very good encryption solution, but it doesn't provide a full coverage in terms of encryption. And there's also competitors with TDE, so if you're not interested in implementing Oracle TDE, but also maybe looking to go across multiple databases such as SQL Server, DB2, and have one solution, there's also third-party solutions out there like Vormetric. Some of the SanDisk vendors also have encryption solutions and things like that. And then finally, never forget about the backup systems, so make sure that you're backing up, you're encrypting your backups. So RMAN has a native solution for that. Oracle Secure Backup does. All the third-party solutions do too. So let's delve into data at rest encryption. So primarily we're talking about Oracle TDE here. And Oracle TDE is transparent data encryption. And so the key here is it's transparent. There's no requirements to change your application or the database structure. So the data model stays the same, the application code stays the same. And so what's happening now is basically Oracle, every time it reads and writes to the disk, is doing that encryption and decryption. You can use a wallet to actually store the encryption keys. And one key about Oracle TDE is that it is an add-on feature. It is licensed separately and it's included with the advanced security option. So there is some cost implementing Oracle TDE in terms of additional Oracle licenses. Some limitations to what you can encrypt when you're using column level encryption. So if you've got foreign keys, constraints used, things like that, you can't encrypt. Certain data types you can't encrypt. And also the length is important. So based on the length, if I have a very long varchar or something like that, I can't encrypt that. But generally it works fairly well. Most applications don't use the columns that you can't encrypt. Most applications are using standard data types like number, varchar, date, things like that. So what does TDE do well? TDE is basically a data at rest encryption solution. So it covers me for a certain set of risks, but not all risks. So if I lose a disk drive, and there are stories about people breaking in the data centers, knocking down walls, driving in with a pickup truck and grabbing a bunch of disk drives and driving away. In that case, you're very well covered. If someone hacks into the operating system level and steals your database files, those DBF files, and I'll show you that in a few minutes, you're protected. If a backup tape falls off the back of the FedEx truck, you're protected. However, once someone signs into the database, that's where TDE stops. TDE provides no protection once someone has an authenticated database session. So once I sign in and I have access to that table, I can actually read the data fully unencrypted. So now the question becomes, is TDE enough? If I have a legal requirement to encrypt data, such as PCI data security standard, is that good enough? The key is we'll leave that up to your legal department to decide. A lot of people say, yes, TDE is protecting me. But again, it's only protecting if someone gets the database files, gets a disk drive. It's not protecting it once you're signed into the database. Some of the encryption misconceptions with TDE, and this is generally the Oracle DBAs have a very good understanding of what TDE does. Unfortunately, outside of the DBA team, a lot of people think, oh yeah, we're encrypting the data, it's providing us a lot of controls. If you talk to IT security, oh yeah, they turned on database encryption, we're great. The CIO says, oh yeah, we're running database encryption, everything's perfect. Well, a lot of misconceptions is TDE is not an access control. Once I'm signed into the database, I see the data unencrypted if I have access to the tables. So I may have those additional capabilities. I may have privileges set up correctly. People don't have select any table. I've locked down who can actually access that data. But unfortunately, the DBAs have full access. Many employees have full access. Select any table is often granted out much more readily than people realize. So people can get often into those tables that shouldn't have access, and the encryption is providing zero benefit here. It does provide something more than nothing. So at least if I lose that disk drive, if I lose that database file, I am protected. But again, anybody with a database session can see everything very easily. So Oracle TDE provides you a couple different capabilities, the first being column level encryption. And this is fairly straightforward. You look through your database, pick off certain columns and key tables, such as social security numbers, credit card numbers, and basically you can do in-place encryption. You can decide how you want that to be encrypted. You can actually salt columns, and if you salt columns, that means if I've got the same value over and over and over, if it's salted, that value will change. So even if I store the same value 10 times, it'll be the encryption will look different for each time. However, I can't index a column that's then been salted. That is one limitation of TDE column encryption. Our recommendation is often to use column level encryption for standard application columns. So as an example, Oracle E-Business Suite has the PRL PPLF table, which stores national identifier, which is social security numbers. That's a very good one to use column level encryption for if I'm not doing the entire database. The second option with TDE is to do tablespace encryption, and we'll show you examples of both of these in a few minutes. If you're running 11G or 12C, tablespace encryption is an option. And what it does is it encrypts the entire tablespace, so it takes each database file, and each of those database files is encrypted. Our recommendation is either to do the entire database or potentially use custom table spaces. So if you've got a package application, you've added some customizations to it, you may know exactly where the sensitive data columns are in your package application, but you may be adding customizations, custom tables and things like that. Those tend not to be as well controlled. So if someone does add social security number, credit card number, or a sensitive data field, that may not be fully told to the DBAs. They may be saying, oh yeah, we're using column level encryption, it's working great, we're picking off the columns we need. What happens when the development team adds in a new sensitive column? Do they know immediately to call the DBAs and say, okay, this new table is being created and it's got a sensitive column? That's one reason we would strongly recommend custom table spaces be done encrypted, because then you're ensured that all those sensitive data elements are encrypted. With a lot more clients now who are moving to entire database encryption, so they're just using TDE blanketly across the entire database. So tablespace encryption does have some benefits because there's certain things I can't do with the column level encryption. So as an example, joins and sorts. If I'm doing that on standard columns and just do column level encryption, in the temporary table spaces, I'll actually get an unencrypted value. If I'm doing it with tablespace encryption, when the data is moved into the temporary table space, it's still encrypted if I'm using tablespace encryption. So that's one key benefit of tablespace encryption. Another one is with column level encryption, I can't do index range scans. So I have to decrypt all the data before I can do that. So the benefit of tablespace encryption is I've got a little bit better performance. I'm encrypting more data, but I do have some performance improvements in terms of some of the things that I can do, especially like on index range scans. So what we'll do quickly here is I'll kind of give you an example of how this works and why you really want to do this at the end of the day. You see a lot of good examples of why do I truly want to do TDE. So in this case, I'm going to create a table, and my table here is very simple. It's basically going to have first name, last name, and social security number. And I'll create 3 different tables. And my first table is basically no encryption. So I'm storing sensitive data in this, social security numbers, and this will not have any encryption. And we'll show you kind of the impact of this based on looking at the database files and if someone steals the database files. My second table is basically I'll create the exact same table, again, first name, last name, social security number, but I'll use column level encryption. In this case, all I have to do is to encrypt using column level encryption is I add the encrypt parameter. In this case, I'm doing no MAC. And no MAC means that I'm not doing any checksumming before I'm saving the data and also decrypting to make sure that it's valid data. This gives you a slight performance improvement and also a slight improvement in the amount of disk storage because it's not also in storing the hash to make sure that the data is valid. And then I'm also doing no salt. You can either salt it or not salt it. If I wanted to create an index, I would have to use no salt because I can't create an index on a salted column. And then finally, I'll create a third table. And this, again, now I'm creating a third table. And this table is going to use tablespace encryption. So what I've done here is I've created 3 different tables in 3 different table spaces. So my first table space is app no encrypt. My second one is app column encrypt. And the third one is app tablespace encrypt. And the only difference between the 3 table spaces is on my table space that's encrypted, when I created it, I actually add a second or an additional option to the create table space, and my option here is encryption using an encryption algorithm. In this case, I'm using Advanced Encryption Standard 256, which is a fairly robust encryption algorithm. And then I'm doing my default storage as encrypt. So again, what this is doing is creating an encrypted table space. And not only is this table going to be encrypted, the entire table space is encrypted. So anything I put into that table space, in this case, this one table I'm creating in the table space, will be encrypted. Interesting point here is there's nothing else here. This is how transparent TDE is. If I have tablespace encryption, I just create the tablespace encrypted, and I don't have to change anything else for my table definition. I'm creating the table definition. It looks just like an unencrypted one, and the only difference is I have to make sure it's going into an encrypted tablespace. So I've created these 3 tables, and now if I go select them, here's the key about TDE. I've created 3 tables. One is no encryption. The second one is column encryption. If you're seeing these running, there's no difference. I'm logged in, I have access to the tables, I'm seeing the data fully unencrypted. I've picked really bad looking social security numbers here so we can actually see them easily in the data. And then for the tablespace encryption. So TDE is providing me no access. I've got access to these tables and I can fully see the data. So if anyone will select any table, even if it's encrypted, can fully see the data. We get that question a lot, especially from like CIOs and things. What do you mean everyone can see the data? Well, TDE is not providing any access control within the database. Once I'm signed on, it's not giving me any benefit. The key is, the benefit is, now what we'll do is go out and I'll actually go look at these files at the database at the operating system level. So I've got my 3 database files, so my no encryption, my column encryption, and my tablespace encryption. And if you go to dataforensics.com or other sites, there's a lot of tools that allow you to look at DBF files. So this is a tool from dataforensics.com or databaseforensics.com. And basically what it'll do is allow me to actually dump out and look at the data within the database file. So I'll first look at my no encrypted one. So this is my, and I'll load all the data blocks. And this is fairly simple because I don't have a lot of data in it. But now I can actually now bring up my database block here. Unfortunately, I'll pick the last one because I know I just added those rows to the table. But as you now can see, all that data is within this data file. And we'll go right to the end because that's where my data got added. And it's all unencrypted. So anyone who steals the database files can just use a number of tools that are available on the internet. And I just grab that DBF file and now I can just start pulling out the information here. And there's some better tools that will actually start dumping tables and things. This is just an example of one that just quickly shows you the data. It's very easy to use. Oracle also has a tool, BBED, which allows you to edit blocks and things like that. So it's fairly easy to dump out the information from the DBF file. So again, this is fully unencrypted. Now let's look at, we'll kind of run the tool again, but now we'll look at the database file that was the column encryption. So the table that was stored completely unencrypted, I can fully read the data in the database file if I was able to hack into the database server, steal the DBF files. Now I'll do the same thing if I've got column level encryption. We'll bring up this, again, the last database block here. And go to the end. As you can see, the only column we encrypted was social security numbers. So in this case, I can fully see the names, but when I start looking at the security numbers, they're encrypted in the file. So even if I've stolen the database file, now I can't even get into, I can't see the easily read in clear text the social security numbers. So that's the column level encryption. Again, the only thing that I encrypted was the social security numbers. I can fully see the names here. Bob Smith pops up, but as you can see, the social security numbers are encrypted values, and I can't pull up that data. We'll run it the 3rd time, and now we'll actually look at the tablespace encryption data file. So this data file is fully encrypted. The entire file is encrypted. And using this tool, when I try to bring it up, I don't even see anything. It can't even read the database blocks. It can't even distinguish if there are blocks within this file. So the file is fully encrypted because I'm using tablespace encryption. So this is basically why you want to run encryption. Someone can't steal your database files. It's not providing me any capabilities when I'm logged into the database, but if someone's stealing the DBF files, if I lose a backup tape, if I lose a disk drive, or I forget to maybe wipe my disk drive when I'm done with it and I sell it off, someone can't get into it and actually start stealing my database files and get into the files and read the data. So this is the benefit of Oracle TDE. And what you're looking at. This is why you want to implement TDE. So if I lose those files, they are protected. Someone hacks into my database server and steals them. The other advantage of TDE is it's very low performance overhead. So basically the impact's now limited to CPU. If I actually then have some of the newer CPU chips, like the Intel chips have AES-NI built into the processor, so it can actually do that encryption and decryption within the processor, not within software, within hardware. It's very high performance. I'm getting very little read impact. And if I actually enable encryption on top, or compression on top of the encryption, I actually do get a performance boost, because what happens is the Oracle database compresses the data first and then encrypts it. So you don't get any degradation of performance when you're doing both the compression and encryption. Column level encryption will give me a little bit more performance impact versus tablespace encryption, because with tablespace encryption, I'm reading blocks one at a time, and that's the performance of the Oracle database is very good there. Where column level encryption is I have to read the block, then I have to actually take the data out of the block and decrypt it before it's presented to the user. There's a couple areas where you can get on encrypted columns, you can get some issues. One is, again, the range scans we talked about. So if I'm trying to do an indexed range scan, I have to do a full table scan if that column is encrypted, unfortunately. So you will see occasionally some queries, individual queries get hit. We tend not to see overall database performance hit. Where you tend to see a problem is one or two queries in an application will really get blasted if you're using column level encryption. So everything will look good, it will work well initially when it's implemented, then occasionally what you'll do is get, oh, one report's really bad, or one screen is not working very well, and what you're doing is, for some reason, there's a range scan using an index, and then as soon as you turn on the column level encryption, now you have to do a full table scan. Sometimes on encrypted columns, when you're doing a join on two encrypted columns, you actually then end up doing a full table scan on both, because all the values, in order to do that join, have to decrypt the values in both columns. Again, if you're now using tablespace encryption, you're avoiding that type of issue, and that's one benefit of doing tablespace encryption. Some of the best practices for TDE, one is ensure the wallet's never backed up with the database. We see that all the time, that people are backing up full servers, so they're backing up both the Oracle wallet, which is set up to hold the encryption keys, and they're backing up the database files with it. That's a key issue that we often see in our security assessments, is that people are doing things like that. So the key is always to protect the wallet. The wallet controls the encryption keys. There's other ways you can protect the encryption keys. We'll talk about that in a second. But always make sure the wallet's backed up. One of the issues with enabling encryption that people don't really think about is, if I lose my wallet, I don't have access to the data. And we've actually seen that in a few cases where the client basically is now, for some reason, there is some issue and the wallet's lost and they haven't properly backed it up. That some of you either accidentally deleted it or maliciously deleted it, and now you've lost access to your data. So make sure that the wallet is first protected so someone can't get into it, but also make sure that it's properly backed up. Then when you're encrypting large volumes of data, you really need to create a new tablespace, and then make sure that when you're done with the old tablespace, you've migrated all that data into the new tablespace, that you shred, get rid of, do a disk wipe. So because basically, unless you get rid of that tablespace very well, the data is still there. Even if I'm removing the data from it, those blocks remain in the old tablespace in the database files. One of our recommendations is, if you're not going to do full database encryption using TDE, so basically encrypting every tablespace, really mix and match them. Don't be afraid of tablespace encryption. So if you do have a few smaller tablespaces, it's fine to encrypt an entire tablespace. You don't get that much of a performance overhead by doing full tablespace encryption. One of the huge issues with any type of encryption is always key management. How do you protect keys? Where are they? How do you make sure that they're backed up and they're properly secured? Oracle uses standard out of the box for Oracle TDE uses wallets to store the encryption keys. A much better solution, especially at an enterprise level, is to use a hardware security module. So Oracle TDE fully supports a number of hardware security modules. One example of a vendor is Vormetric. So this is outside of the database server. So what you now do is have a very hardened, redundant, fault-tolerant appliance, and the keys are stored there. So as soon as the Oracle database wants to start up and get a key, it knows it has to go out to the secured appliance and pull the key. And there is some handshake back and forth to make sure that the secured appliance is providing the correct key to the correct server. But again, now I'm not back. I don't have the key ever stored directly on the server. The key is stored in this hardened appliance, and it's a much more secure alternative than using the Oracle wallet. And Oracle has a number of HSMs they work with. So the key is, if you are implementing Oracle TDE, work with the IT security team, work with the rest of IT to say, okay, yes, why don't we have a HSM for our entire enterprise? We should be storing all our certificates in there and things like that. And Oracle TDE works really well with it. It's a much more secure way to store it, rotate keys, and things like that. So if you're not, Oracle TDE is a very good solution for the Oracle database. It's very high performance. It works very well. It's very well supported by Oracle. In some cases, Oracle TDE may not be the best solution for database encryption. There are several other products out on the market. This is just an example of one of them, Vormetric. Vormetric works very similar to the way Oracle TDE works. It works at that I/O level. Instead of doing it directly from the database, Vormetric is now adding in a layer at the operating system level. So every time the database reads and writes to the database files, it's basically passing through a layer that's then encrypting and decrypting. And then basically there's agents running within the server, so only the Oracle user running certain Oracle programs can actually access those database files. So it's providing a fairly robust solution here. The reason we see a lot of people implementing Vormetric is not just maybe for Oracle, but if I'm running a number of database platforms, I may want a common solution. I don't want to have to implement Oracle TDE, SQL Server TDE, a DB2 solution, a Sybase solution. Vormetric can provide a common solution across multiple database platforms, across file system platforms, applications, and things like that. And we don't have a relationship for Vormetric. Vormetric is one of those products we've worked with closely at a number of clients and have seen it successful. So again, Oracle TDE works very well, but there are other solutions here. So just don't stop at Oracle TDE. If you are looking to do a database level encryption solution across every single database platform, there might be some other good solutions out there on the market, and definitely be looking at what's there, what's available. There's a number of auditors on the call today when we look through the registration list. So I wanted to talk about each of these topics. What should you be auditing? So if you do have a database that you do need to look at and audit, what's important? So if the DBA tells you that, oh, we're running Oracle TDE, what should you be looking at? The first and foremost that we've talked about is key management is critical. If they're using the wallet, how is it stored? Is it auto open? So the Oracle wallet has a feature called auto open. So then as soon as I start up the database, the wallet automatically opens up. I don't need a password. I don't need somebody who knows that key to open it up. It does have some protection, so if I can actually lock that wallet to that server, there are some protections there. So you need to look at how that wallet's done, how is it protected, what are the file permissions on it. Is a HSM, a hardware security module, used? So is there additional protections to the key so it's stored outside the database server? The second key question is, okay, is column level or tablespace encryption being used? So what's actually being encrypted in the database? And then what encryption algorithms are used for each of those items? So there's really two different views within the Oracle Data Dictionary that tells you what's happening here, and I'll show you those quickly. So if you do look at a database and say, okay, what's being encrypted within this database, there's two different data dictionary views. So if you're looking at the tablespace encryption, this is fairly simple. You just basically look at the, I have a semicolon here, sorry about that. If you look at DBA tablespaces, you can basically pull up, there's a column called encrypted. I only pulled up a couple of table spaces here that we've been working with. And if it's basically using TDE, the encrypted column will be yes, or it'll be no. That's how I kind of check if tablespace encryption is being used. And then I would start looking at the DBA tables, mapping those tables in that table space to actually see which tables are encrypted. If you're doing column level encryption, the data dictionary view is basically DBA encrypted columns. And that will now show me that in the app schema, my table SSN column encryption, the column name SSN is actually being encrypted. It's using AES 192, no salt, and it's then got the no MAC, so it's not doing any checksumming of the encrypted values in and out. So those are basically what you'd be looking at, trying to review to say, okay, is this the data? The hardest part here is knowing, okay, is every place social security number or credit card number or bank account number, is every single value encrypted? That's very difficult to find out. Integrity, during our security assessments, we have tools that look at that and do calling of the database. But if you're just an auditor trying to figure out, is every single social security number in the database encrypted, that can be a fairly lengthy process to try to figure that out, and there's no easy solution. So that's data at rest encryption. So that's when it's on the disk. Again, as we saw, once I'm signed into the database, there is no access controls. It's basically the values are unencrypted as long as I have access to it. So if the permissions in the database are not set up appropriately, if I'm granted out select any table, even if it's encrypted using Oracle TD, I can fully access it. The DBAs can access the values if they're using the sys or system account and things like that. So how do you then protect against that scenario? To protect against a scenario when someone's logged into the database, it's data and use protection. And now this becomes much more complicated. This is not a simple, transparent solution. I just don't go buy a product from Oracle, spend about 30 minutes to implement it, and I'm up and running. If I need to truly now protect the data from even the DBAs accessing it in the application, things like that, I have to spend a lot more time and effort, and most likely require changes to the application. So the key two solutions for data and use encryption is the application basically is rewritten, and every single time it reads and writes the data, I encrypt it and decrypt it. I use a standard set of encryption routines, hopefully. And also those encryption routines can also now start to check security. So when one accesses that column and tries to run those routines, it may be checking if I have a specific database role, if I'm a specific database user, I may have an application role, things like that. So even within the application, an example of the Oracle E-Business Suite ERP system, the way it does it for credit cards is if it's not the app's user, it won't let you pull back the encryption key. Again, it's now providing some level of protection. So if you're not a specific user in that case, it's not letting you access it. In certain cases, if maybe I have application roles that are defined within the application, I may not be able to decrypt the values. The second solution is slightly more transparent. I don't necessarily have to rewrite the entire application, and this works for custom applications, is a view trigger solution. We've seen some clients implement this with success. Again, this is much more for custom applications, doesn't really work with package applications. But what I can do is, if I know I want to have encryption, I don't want to necessarily rewrite the entire application, but it's not that complicated of an application. I can now start creating views and triggers for every key table that's got sensitive data. So when someone reads it, instead of reading the table directly, they start reading through a view, and the view for that column would then call the decryption routine. And that decryption routine, again, could be having some security checks in it. Then whenever I write to the data, I basically put a trigger on the table, so whenever I do insert or update, I then call an encryption routine. I encrypt the value before it's written in. So now sitting in that table, the values are all encrypted. So then I start to control access. Maybe I'm not protecting fully against the DBAs, but now I'm probably providing some protection against somebody with select any table. So if I can now put in my key management correctly, my routines correctly, even if someone's got select any table system privilege, they won't be able to read the data. When they start querying that table, all the values will be encrypted. And unless they can figure out where the encryption keys are and how to call the encryption routines, if they don't have access to those encryption routines, they probably can't actually see the data. For DBAs, this becomes a little bit more complicated because they have the system account. They can probably find those values. But then again, if I implement a database vault, I can now protect potentially even from the DBAs. So I'm doing these custom application and trigger view solutions. I should be actually using some standard APIs. So the Oracle database comes with a number of encryption routines. The key one is DBMS Crypto. So this is a standard Oracle database package that does encryption and decryption. It also does hashing, and it supports most of the key encryption and hash algorithms. So each Oracle database version releases and supports some of the newer encryption routines. Usually it's not the latest encryption routines. As an example, Oracle 12c just started supporting SHA-2. Oracle 12c also now supports AES 1024, I believe. So now it's adding in some of these newer releases. So if you are on an older version, let's say 11.107, you may not have some of the latest encryption routines. Through 9i, Oracle did have a second encryption package called DBMS Obfuscation Toolkit. That's been deprecated and should not be used. One of the things we see a lot of times in custom code is they're using the older encryption routines. So instead of using DBMS Crypto, they're using something else. Any custom code, any applications should always be using DBMS Crypto because that's supporting the latest algorithms and latest hash algorithms. Another option is to use some third-party encryption routines. So instead of using the standard out-of-the-box Oracle database ones, you can actually purchase some robust third-party algorithms. One of the key ones in the market is a company called Voltage, and they basically what they do is to deliver you some libraries that work with the Oracle database. The key about the Voltage API is it does format preserving encryption. So you may be converting an application now to support encryption, but one of the keys is, let's say you have a column of social security numbers. You assume that column was 9 characters. The application is hard-coded, everything is 9 characters. You may not want to change that, and what format preserving encryption does is if you've got a value that's 9 characters long, format preserving encryption keeps it at 9 characters. So it's encrypting the value and storing it as a 9-character encrypted value. Because typically encryption always makes things larger. So if I have a social security number and I start encrypting it using, let's say, a standard encryption algorithm like AES, Advanced Encryption Standard, that now becomes 18 or 24 characters. Well, I may not be able to store that. I may have some limitations, and so when I'm converting my application to start storing things encrypted, I may not be able to store that 24 characters. I would have to create new columns or change the column sizes, and there may be some reasons I can't do that. Format preserving encryption actually is very powerful that now I don't have to do that. I can just now start implementing the API, storing it in the exact same place it is. So it works fairly well. So there's lots of different options to use this, but the key is what we want to see people using is some standard APIs, either DBMS Crypto or purchasing some standard libraries rather than writing their own. I can't tell you how many times we go into a custom application and somebody pulled off some code from the internet or wrote their own encryption routine. It's much better to use a standard encryption routine like ES 128 or something like that than trying to send your own. So again, back to the auditing the application encryption. So for the auditors on the call, this is one of the it's very easy to audit TDE, so you know what's being encrypted. To figure out exactly how application encryption is working, what's being used, you now start to have to delve into code. Either look at the design documents or start looking at code, and to make sure it's being done right, you need to be looking at code. Again, key management's critical here. I can't tell you how many application security assessments that Integrity does, and the way people store the encryption keys are they basically write a PL SQL package, they hard code the encryption routines in it, and then they think to protect it, they just wrap the code. Wrapping PL SQL code means when it's stored in the database, the code is encrypted so you can't easily read it. Unfortunately, there's many ways to unwrap PL SQL code. So if you've got an encryption routine and you've hard coded the keys and then you've wrapped it, that is not a very secure method to do it. That should be not done under any circumstances. There's lots of different ways to do it, but the problem is you have to spin your own key management routines. So there are ways you can use the Oracle wallet from within the Oracle database. You can use hardware security modules to pull in the keys and things like that. So you need to make sure that the keys are stored properly, they're protected, and that there's a method to rotate them. Hard coding keys is not acceptable. Then the second part is what libraries are being used. So again, you should not be spinning your own encryption routines. You should be using some standard libraries. The Oracle DBMS Crypto is great. The products from Vormetric and Voltage are also very good products. And then finally, what actual encryption algorithms are being used. A lot of standards, like if you're doing payment card industry data security standard, which is PCI, doing credit cards, they mandate exactly what encryption algorithms you can use. So you must be using an encryption algorithm like AES 128 or above. So that's data in use. So that's basically when data is stored in the database and now I'm trying to access it. And then finally, the last topic is data in motion. So when we start talking about how data is being traveling across the network between the client and the server. The key option here is Oracle SQL Net Encryption. So SQL Net is the protocol. So if I've got a client, and when I say client, that could be someone's desktop running SQL Plus or SQL Developer, or it could be an application server running some JDBC code that's then talking to the database directly. So SQL Net is the protocol that's going between the client and the server. And the client, again, may be an application server. SQL Net Encryption used to be actually a purchase add-on option. So it used to be included with Advanced Security option. Now it's actually available with the database for free. And it's fairly easy to configure. So you basically just turn on a couple options in the SQL Net Aura file on either the client or the server, and that will start enabling SQL Net Encryption. The reason you want to do this is between the client and the server. If I do, let's say, select star from Social Security numbers, the data as it transmits back to my desktop is fully clear text. So if anyone puts a sniffer on the network or does a trace or something like that, they can now capture all that data fairly easily. One interesting thing about the Oracle database is when I sign onto the database and I put in my database password, that actually is never sent over clear text. Even if when I'm not using encryption at all, the database password is actually protected when it's sent back and forth between the client and the server. That's one piece of information, so you don't have to worry about that. The key here is any other sensitive data. So when I'm doing a query and I'm bringing back data, is that data encrypted? And SQL Net Encryption is actually fairly easy to set up. And so you basically go into the SQL Net Aura. And by the way, it's not enabled by default. It's basically set to accepted by default, but that means it will not be turned on by default. So with your data center, this is probably not an issue. The question now is who's out on the network querying data, who's actually accessing that data. So all I have to do is in one or the other, so I can configure this either on the client or the server. We always recommend it being configured on the server because that gives you a centralized point of control. And you basically set it to accepted, rejected, requested, or required. And so you turn it on. We always recommend setting it to required, so now you enable it. And then you pick a different algorithm. And at the bottom of the slide, I've included all the algorithms supported with Oracle 11.2. And again, you want to be using robust algorithms. So AES and 3DES are government accepted standards that are fully vetted by PCI, the US government, other organizations that say these are the most robust algorithms available. They don't have a significant performance overhead because a lot of these now are implemented in like the chips. So Intel supports AES within the chip. So Oracle will be able to use that. The way this works is you set server parameter or you set the client parameter, and depending on what the values are, will tell you if it's actually on or not. Again, we always recommend required because now if I turn it to required, it's turned on because the client default will be accepted, the server default's accepted. So if I set the server now to required, I will always force encryption on whenever possible. So this is kind of a key chart. You can set it to rejected, and if someone requires encryption, you'll get an error message, things like that. So the key here is maybe just turn on required on the server, and now any client coming in will enable SQL Net Encryption by default. The only issue that can come up here is if I do set it to required, some older clients, so if let's say I have a really old application stack, but I've upgraded the database and the application stack may be an 8i client talking to a 12c database, they may not be able to talk, and they may get an error if I require encryption because the algorithms may not be compatible, or the encryption standards that Oracle uses may not be compatible. So you may get some errors on some really old clients connecting to newer database versions. And that's something you just need to test out. Very seldom do we ever see that as a problem. It's just when you get some really old applications talking to a newer database version. If you're an auditor, what do you need to be looking at? One of the first nice things is you can actually check if, for different connections, if encryption is being used. So if you look at the $V session connect info dynamic view, it'll actually tell you by session if encryption is being used. So there'll be 3 lines returned a lot of times for each connection, and one of them will be encryption service. So if you get a line that says encryption service, you know that that session is actually using SQL Net Encryption. You don't know what algorithm is being used, but at least you know it's enabled. So then the second piece is you review the SQL Net Aura file, and with that file you're looking at the encryption settings to see if it's actually enabled. One of the key things you need to think about, though, is if you turn on encryption. We've actually seen this with some clients. Again, across the wire, across the network, encrypting the packets. Some organizations have implemented auditing tools such as Imperva and Guardium. These tools can implement in different modes. One of the modes is they sit there as a network tap, and they're basically sniffing the network, and they're watching the SQL Net packets go back and forth, and that's how they do their auditing. So they have zero performance overhead on the database server. They basically watch the network traffic. And oh, by the way, if I now turn on encryption, I actually blind those tools to the traffic. They can't see the SQL Net traffic going back and forth. Both those tools have options to put an agent on the server, database server, and then they'll be able to see the traffic. But if you're running Imperva, Guardium in network tap mode and you enable encryption, you can actually blind those tools to see the audit trail. Again, somebody else can do that by if they just actually go into their client and they put required as the encryption setting on the client, then they can actually blind those tools also to their own traffic. That's one way to avoid some of the auditing tools if they're set up in network mode. But again, that's only if it's in network tap mode. If you're running the agents that are on the database server, this is not a problem. But again, we've seen this with a couple clients who are running those tools. They've deployed network taps. They then want encryption, and then they wonder why they're not seeing anything on their auditing tools. So it's a kind of a high-level overview of the different options of encryption. Kind of went through to show you what's actually happening behind the scenes, how that should be working, what you're trying to actually protect, where there's benefits, then also where there's some disadvantages. So again, encryption is not an easy solution to roll out, especially across a large number of databases. It does provide a lot of benefits, but it has to be, you do have to have a strategy. You have to look at this very carefully on how you're going to do it, what you're looking to protect, why you're trying to protect it, and what are the risks. So one of the things that we do for our clients is when we do an assessment, we'll actually come up with different solutions, and based on different risk scenarios and threats to the organization. Are you trying to protect against DBAs? Are you trying to protect against people stealing backups or database files? And how you do this, how you're going to do encryption, how you're going to do access controls, and how you're going to do auditing all play in this together to kind of protect. How do you protect sensitive data? Encryption is one of those. Access controls is another. And finally, auditing is the third. I'm just going to give you a little flavor of how you should be going about this and what you should be looking at when you're thinking about encryption. I will turn it over to Phil, see if there's any questions.
Thanks, Steve. Very informative on encryption database, Oracle databases. Yeah, we have a couple of questions here. The first one, will TDE eat more space?
There is some performance overhead in terms of disk space for TDE, but again, we actually recommend a lot of people implement compression at the same time. You'll actually get performance improvement, space improvement if you implement both encryption and encryption at the same time. But again, whenever you're encrypting data, it always expands slightly. And just depending on the type of data and the encryption algorithms used will depend on how much more space is used.
You mentioned speed, performance. That was the next question. Is performance slower?
There is a performance overhead. But again, you can mitigate most of that by using specific algorithms that are supported by your CPU. So if you have Intel CPUs, Intel has AES NI, and so if you implement an AES encryption algorithm, it'll actually be processed within the hardware, and TDE does a very nice job at that. So yes, you can see a 5 to 20% performance overhead. Again, it's very negligible. Typically when people are implementing tablespace encryption, they're not complaining about it. And with column level encryption, we typically see individual queries getting hit badly because they're ending up having to do a full table scan, versus people say, oh no, we're getting a 20% performance overhead. No, it tends to be, oh, no, we're not seeing any issues. Maybe 1 or 2% CPU utilization increase, if you can even see that regularly. But oh, by the way, that one report just takes 20 minutes to run where it took a minute before. Those are the type of issues you tend to see, versus just saying, oh yeah, no, we're seeing 30% performance CPU overhead or something like that. No, you tend not to see that with Oracle TDE.
And the next question, does TDE work with the eBusiness Suite?
Yeah, so Oracle TDE is fully supported with the Oracle eBusiness Suite. We've got clients who are using it for either specific columns, such as national identifier within HR all people F table, or they're doing full tablespace encryption. So they're just encrypting the entire database. They're doing every single tablespace. Both solutions tend to work well. The one key about Oracle eBusiness Suite is Oracle eBusiness Suite can store credit cards, and its credit card encryption is actually using application level encryption. So you don't need to, if you're just doing credit cards, you don't need to use TDE just for credit cards, but we highly recommend using some solution for Social Security numbers, because there is no application level encryption solution for Social Security numbers. So using TDE is really the only effective way to provide at least some encryption for Social Security numbers when they're stored on a disk. But again, anybody who then accesses the application will see the data unencrypted if they have selected any table or the DBA. So then you need to, again, look at access controls and auditing as additional layers.
Okay, next question. What are the performance impact of SQL Net Encryption? Could you share some numbers / percentages you've seen at clients?
Yeah, so in terms of SQL Net performance overhead, we're seeing maybe 3 to 4% overhead for high volume applications. So typically if you're seeing very high transaction loads from application servers, that's where we'd see the performance impact. We tend not to see it if you've just got a data warehouse and just some people querying data where most of the processing is happening. But when you're doing large numbers of small transactions or pushing very large volumes of data in simultaneously, but we tend not to see that. People tend to use like data pump and other tools versus doing it by SQL Net. So the only time we ever really see a huge problem is when you got very high level transaction volumes from application servers. And then again, that's only maybe 3 or 4%. In some cases, we'll actually create a separate listener then. So you'll create 2 listeners, one being encrypted, one being not encrypted. So your application servers are running within your data centers. Those you'd be running unencrypted because you're assuming they're pretty much connected to almost the same switches or pretty close together. So the risk of someone sniffing that traffic would be very low. But what I'm really trying to protect is my far-flung SQL Net clients who are way out on my network, people using SQL Developer, SQL Plus, or local desktop tools to bring up the data. I really want to encrypt that. So that's one solution that we've implemented for when we did the performance overhead, just because they were running massive amounts of transactions through the Oracle database, and each transaction was connecting from a application server.
Next question. Does the database memory contain clear text or encrypted data?
Based on if you're running column level encryption or tablespace encryption, that will matter. So column level encryption tends to be clear text in memory, and tablespace encryption will be the blocks are encrypted within memory. So that becomes a little bit of a difference in some of the advantages of tablespace encryption. Redo logs will be encrypted. So there are a couple other issues there outside of just the database files in terms of redo logs and things like that. So that's always a consideration with TDE.
All right, Steve, I think that wraps it up for the day. I want to appreciate everybody. Thank you to everybody that has spent the last hour with us. And don't forget that our presentation, our webinar next month on the 25th is database security in the cloud. And also, if you're going to Collaborative 16 in April, be sure to look us up. We'll have four different presentations there. So look it up on the agenda and mark it down, and we'll see you out there. So everybody have a rest of a great week. Take care.